Hi everyone, we're going to be starting example 3 and 4, which is on evaluating logarithms. So we're going to find what the value of these logs are. They actually equal a nice and pretty number, but you will figure out what those are in just a moment. So when we are evaluating logarithms, the first thing we need to do is to convert these things into an exponential. But you're probably like, holy hot dog, Miss Long, in order to convert to an exponential, we have to have an equal sign. It has to equal a number. Okay, so to make our lives easier, whenever we solve logarithms, we're just going to set it equal to a variable. That way we can solve for the variable. Okay, so each time we do this, we're going to set these bad boys just equal to x or to whatever variable you want. Alright, so now we can convert this thing into an exponential. So remember, the base of the exponential is the base of the logarithm, which the base of the log is this little guy right here. Okay, so the base of our exponential is going to be a 2. And then remember, the little shortcut is these two will trade places. Okay, so the x will become the exponent on the 2. We're going to have our equal sign. And then the 32 is going to hop to the other side of the equal sign. Okay, so from here, before we keep going, in order to figure out what that variable is, we're going to be incorporating this lovely property right here. Okay, our goal is going to be to get the same base on both sides, because if we get the same base on both sides, this is just a property. If I have c to the x equals c to the a, okay, anything that has the same base, okay, that would mean their exponents have to be equal. So this implies that x equals a. Okay, so if we can get the same base on both sides, we can set those exponents equal to each other. So that is going to be our goal. Okay, so we want to think of a number that goes into both 2 and 32, which 2 is a good one. So 2, our goal is to get 2 on both sides because 2 will go into 32. Sorry, 2 will go into 2 and 32. Okay, so we need to figure out 2 to what power gives us 32. So let's see here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Holy hot dog, that is 2 raised to the 5th power. Alright, and now, since we have the same base on both sides, if you notice we have a 2 on both sides, using this roll up here, we can set those exponents equal to each other. So x equals 5. Okay, so all that means x is what the log equals. So secretly, log base 2 of 32, secretly all that is a 5. That's what you just solved for. You solved for x, which x is 5. So for your final answer, I would accept x equals 5 or log base 2 of 32 equals 5. Either way. Alright, so example 3 is finished. Now example 4 is very similar, so if you'd like to pause the video and fast forward to the end, go ahead and do so. So I'm going to continue on with example 4. Alright, same idea. So the first step, we're trying to convert this bad boy into an exponential first thing. Okay, and remember over here, in order to do that, it must equal something. So I'm going to set that bad boy equal to an x. Okay, then we're going to convert it into an exponential. So the base of the exponential is the base of the log, which the base is that little number hanging out with the log, the 5 right here. So that is going to be the base of my exponential. And then remember the little shortcut, these two are going to trade spaces. Okay, so the x is going to become the exponent on my 5, and the 125 is going to hop to the other side of the equal sign. Okay, or you could do that little roundabout method I've shown you. 5 raised to the power of x equals 125. Okay, either way, whichever way makes more sense to you. Alright, then we're going to be incorporating this property, so we're trying to get the same base on both sides. So looking over here, when I'm trying to come up with a base that will work, I want to think of a base that will go into something on both sides of my equation. So I want to think of something that goes into 5 and 125, and we're not talking about 1. 1's not really going to help us. Okay, so a number that goes into 5 and 125, the only number is 5. Okay, so I'm going to have a 5 on both sides. I'm going to bring down that x. So I need to figure out 5 to what power will give me 125. So let's see here. 5 times 5 is 25. 25 times 5 is 125. Holy hot dog, that exponent is a 3. Alright, so we have 5 to the x equals 5 to the third power. And now, since we have the same base on both sides, 5 and a 5, we can set those exponents equal to each other. So that means x will equal 3. Bam! That one is donezo. Okay, and remember, all that's saying is this log right here, that whole log base 5 of 125, that is secretly just 3. Those are two equivalent statements. That is 3. And that's it, you guys. Okay, so we're going to be moving on to example 5 and 6, which these are pretty much the same thing, but are a little bit trickier. Okay, so the next video will be on 5 and 6. It's been a blast.